Hello and welcome back to Poor Man's Electronics Bench. I am going to finish the work on this Sencore RC121 unit by adding a few niceties, embellishments, or accoutrements, fancy words for additions, which will keep some metal damage from happening while in use and keep it in tip-top looking shape for years to come. Rubber feet, plastic edge guard, a clear acrylic coating with clear heat shrink over the steel carry handle, and stainless steel hardware will be installed all around to finish restoration. This will conclude work on this unit, but another RC121 waits in the wings, which is in need of replacement of the power resistor arrays due to abuse by a previous owner. I will cover all of this in this part of episode 10, with more coverage to follow with work on unit number 2 on a future part. And now it is time for all the king's horses and all the king's men to get to work and put the Sencore back together again. And I have done some work on restoring the finish of the item. I don't know if you noticed, but I did manage to get a couple of coats of a nice acrylic clear coat on here, clean up the front as well as I can, and try to touch up some of the black paint, but I kind of missed the nick there. This bottom surface I sprayed some Restoral metallic silver on just to give it a little better coat of something, and of course I covered up all the jack entrances and switches with some tape and had to loosen a bunch of stuff in back, but I managed to clean up a lot of the air and flux residue. There's still little bits and pieces here and there, but going to try to get to the point where I can clean up things a little more and hopefully not make a bigger mess putting them back together. So of course I had to take all the switch assemblies out. Going to put him aside for now. The smaller switch assembly, I ended up going over it good with some flux remover and a brush and clean that up as well as I can, and I got some of that odd shiny coating off some of the old carbon copper resistors as well. Cleaned them up and cleaned off a lot of the flux residue. I'm going to go through re-lubricate the contacts. I have to lubricate the shaft, and I have to lubricate the indexing portions as well on both of these switches now that I can get access to them before I put them back together. The handle to the box I ended up clear coating, cleaning up. What I did is I ended up putting this in the Sunnyside rust remover bath, and it cleaned up very well, and I got a couple of coats of clear on it to seal it. And I'm going to do a little bit better coverage on that as well. I'll get to that when I get to the handle. And I got my two switches I have to replace on the front panel. I have new hardware for those. The knobs I cleaned up, and it seems like these older Sencore and some of these Ico knobs, the paint comes off fairly easily on the white, so I've got some paint marker pens. One is a kind of just like a green color. I've got a white one too, but I decided to use the green. I kind of like the looks of that. It adds a little bit extra contrast. It's a brighter color, gives it a little personalized touch. And my switches, I have to do the same thing with that other switch assembly. I have to go through and lubricate the indexing indent spring loaded part, clean that up a little bit. But the capacitors are all still ready to go and get reinstalled. I do have one piece of metal. It held the back of the, I don't have it right with me. I'll find it in a minute though. I'll show it to you when I put it in. It's the part that holds these capacitors in. I ended up stripping that down in some of that Sunnyside rust dissolver. and putting a coat of Rust-Oleum hammer finish paint. It seems to be a pretty durable paint, especially once it dries. And then this guy here, I don't know if you remember, it kind of had like a grayish tinge to it with had some general staining and had a little rust on the inside. And I ended up going through and soaking this in the rust remover bath, turning it in a couple different degrees rotation in the bath until I got most of the areas covered and soaked in that rust dissolver. I then put a coat of a Rust-Oleum satin black on it, and it was a light coating. It was more just to add color than anything. There was one spot right about here that was dented. I straightened it out the best I could and just sprayed it, and I'm going to go over something to cover that up with. But this came out fairly well. I'm happy with the results on that. There's one addition I'm going to make to this as far as the niceties on things. I noticed that this particular cabinet did not have any type of rubber feet. It just had these metal bump outs, and I have sourced some kind of strange washers. I just figured I could possibly use those feet because they had holes in the middle and they make glue around those bumps. They're called isolateds. They are sorbethane plastic or rubber. It's kind of like what you might consider an elastomeric rubber. It's really stretchy, and it has some sort of like a tacky, oily feeling to them. And the problem, it's good and it's bad, because it will like stick to a glass surface without any adhesive. A glass or a smooth metal surface without any adhesive. Not terribly well, but it kind of sticks well. But the weird thing is it does not want to hold glue. And I tried a couple of attempts of gluing those feet to the bottom. First I tried what would be considered a hobby glue, Eileen's Original Tacky Glue. This may be a step up from regular Elmer's, and that did not hold very well. Then my next attempt was a B7000. This is kind of like a cross between silicone and your old Tester's bottle airplane glue. And you can probably get a good buzz off it too from the way it smells. But this one does not want to hold either. And the only thing I really found that's working out well is it's called Scotch Extreme Mounting Tape. This stuff it has like the same texture, that kind of texture or feel that the rubber in these mounting washers, grommets, isolators has, but the adhesive on this seems to stick very well to this, and it sticks very well to the paint. So I'm going to go through and, well, I've got to do some glue removal here. Bear with me a minute, because I left, unfortunately, I didn't turn all this glue up, so I'm going to come back to it in a second after I get the glue cleaned off of all these feet. And after a little practice, I got 3 or 4 done. Well, the first one I had done for a while, and one thing I learned is that I need to cut a little relief in the adhesive on this one, because of the lip of that front panel. It comes underneath to mount. The screw goes through the front panel, through the base to secure it. So you need to cut yourself a little bit of relief in that area. So that's what I'm going to do with the last washer. I have to cut myself a clean edge on it. Since these things have had a little bit of handling and exposure to surfaces and glues, I'm going to take the surface I'm going to mount the tape onto and just clean that off with some alcohol. Clean that area off as well. This tape really has some stick to it on this. It's surprising. The rubber on the tape is just about exactly the same as the rubber on the washer. Not trying to be too exact. If I had a production line to do here, I'd make some sort of punch to chop good clean hole. And I just want to go back through, get another clean edge on this. And my last cut, got to remember that I don't want to come all the way to the outer edge of that washer, so I'm just going to cut a strip off my tape. Place it on here. That should give me my relief. Let's come along and trim up the excess. Now the hard part is now, depending on how old this tape is, this particular roll of tape I think is probably over 5 years old, and that backing really sticks to it. I'm got a little bit of a degree of difficulty getting it apart. I'm using one of my soldering tools to get under it, get under that lip. And hopefully, holding it out there, I get a good pull, and I got it away pretty clean. So that's a good one. Even though it sticks to that washer, it's not the greatest, but it's still better than the two adhesives I tried before that. And I don't know if silicone would be any better or not. I got lucky and got a good pull on that one. And the only thing I need to do, since the cabinet foot has a bit of a hump to it, which is why I chose to do it this way instead of drilling any holes and putting any mounting screws in. I'm going to come in with a pair of scissors and start to work my way around. And I'm just gonna hope that this holds on for a fairly long time period. It should, because the cabinet and the weight of the unit should help to just keep it stuck down over time. And this isn't as with some of the other work or modifications I do, I'm not claiming this is a be-all end-all way of doing things. Everybody can come up with their own way of sticking feet on a device like this if they want, and if you have some suggestions that you might think work out better, you can always share them. And they don't want to pull off easily, and over time that glue will help them stick a little better. So I'm going to go with that as my first part of modifications to the cabinet. And the second thing I might as well work on is, well, I'm going to wait for the handle for a little later. That might be second to stuffing everything into it. I should probably work on the front panel a little bit. Well, you know what, I'll do the handle. It's kind of funny, I ended up putting that, getting a little sparkle in the coats of acrylic. I sprayed that metallic silver paint after I put the first clear coat down, and then I put a second one on top of it, not really realizing that I did that, but that doesn't hurt anything. It just looks kind of funny. And I was thinking too, along with the clear coat, is that that handle is really something that, of course, people are going to be touching a lot when they're moving things around. And what I figured I'd try is to put some clear heat shrink, and I sourced some online. It's a really thin heat shrink, and it's should shrink down enough where just to give it that little extra bit of protection. I'm going to try this out. Even though it's got the clear acrylic on it, you've always got a chance of some acid off your hand having an effect on it. It looks like I got it fairly well centered. I have to hope that it behaves itself well. There are thicker heat shrinks available. This isn't as much for electrical insulation, I don't think, as a protection. I don't think it's really insulation rated. As far as helping for mechanical protection, it will probably do a good job. It looks like it's behaving itself. It's cupping to the cuts a little bit. And it's got just a few small blemishes in it. But it does look fairly attractive. It just gives a little bit extra protection, because you're always going to be picking it up by this, and I'm sure that's how they've got corroded to begin with. And I went through and I did purchase some new hardware for things. Since I'm trying to make this as pretty as possible, I did end up getting some stainless steel hardware replacements for most everything, at least the visible parts that are going to come in contact with acids from people's hands and things. Well, this had plastic spacers with some nut and bolt hardware. Probably give these a little cleaning. Seems to be a fairly sturdy plastic, which is good. And this is all number 6 screw hardware. Nothing too complicated. flat washer in between. I think I cut these screws were 1.5" screws. The originals were 1.25". They've got just a little, I cut these down a little bit. They're just a touch longer than the 1.25". I'll allow for another washer. I'll hopefully help keep the top of the chassis from bending and flexing. Oh, I know I had here we go. Another hardware nut and bolt. After I get these installed, I can put some Loctite on them. Although they have lock washers too, just the fact that they're going to be mechanically binding the handle, and the handle is going to get more vibration than a lot of things on it. It might want to work its way loose even with the lock washers. As even when I first received this item, the lock washers were installed, but yet the hardware was loose. This screw, I didn't clean the threads up as well on it as I wanted to. It's a little stubborn. It should, oh man. That looks like a number 4 nut. I don't know where I picked that one up from. The lock washer was the right size, but that hardware nut's really small. Okay. Let's have to slide it. Slotted bolts. Okay. That's a good start. That cannot be a number 6. Oh, maybe it is. It just likes it just wants a good clean thread on the end of it. Maybe I'll try to reuse it. Pesky little guy. I know these are all the same thread size because I ran the same nuts on all of them. I'm going to go off camera and get this guy into place. So I shall be back with some more work in a little bit. Okay, our cabinet has a handle and feet, and now we are going to go for our capacitor array bracket that goes in the back. There's two holes that are drilled through the back, and I'm going to probably get those screws started, but I'm not going to tighten them yet because I'm going to put the capacitors in place once I get them all connected back on the front panel. These are number 6 by 1/4 inch screws. You can probably go 3/8 if you wanted to as well, but I'm replacing these with some stainless, and I'm just going to leave them a little loose to leave a little more space for the capacitors to slide in. That'll tighten them down. I found a piece of the double-sided sticky tape laying around on the bottom foot of that, so they definitely have an affinity for each other. So that one's in place, ready to go. And now I have to proceed with the work on the panel. I'll move the camera a little bit, reposition my lighting. There's a few items to address besides, well, I left a messy line of paint because I sprayed along the bottom of this panel as well just to cover up some corrosion. Gotta get my new hardware switch, my new slide switches in. I did state earlier that they would be direct replacements as far as size, and they are, thankfully. My only qualm is that I ended up having to remove the spring loading function on the switches, but that was my error in ordering the wrong components. In the interest of not boring people to death too much, I'll probably just speed through a lot of this reassembly, because it's just going to involve putting switches back in, lubricating them, things that I've shown in other videos already, so it's nothing too crucial. And after that, we'll get back to some of the finishing touches on the front of the panel. And I've run into a self-created problem. I'm going to have an interference problem. I'm going to have to find some smaller hardware nuts, because it seems that the size of the nut itself interferes with the switch. I'm either going to have to find some smaller ones or grind these down, or I can try to position them with the flats close to the switch. The inside of the switch, that one's pretty close. It's a little better, but still not ideal. Doesn't seem to have a full length of travel. You see, this one's got a traveling all the way to the ends of the metal faceplate on it on this one, and on this one you can see on the inside it's not quite made the trip all the way to the end of that metal faceplate. So I am going to have to try some grinding, I think, on the flats of one of these nuts in order to get it, just to have a full travel to make sure that there's no problems. So I'm going to go off camera and do a little grinding or filing and come back in a little bit. And I'm back, and it just goes to prove it's always something, but I ended up taking a grinder to one of the flats on each one of these 632 hardware nuts and filing them, cleaning up a little bit, but it gave it just enough clearance where it seems like the switch is now able to go back and forth in its full travel. You can see the base and back of it on both sides. It's bumping up all the way, so it should be making a good connection now. So I wish I could have got some smaller hardware, but I went to a local hardware store and pretty much got what I got. So I'm going to zoom out, get back into focus, and continue on with reinstalling things, and I'll do it at an expedited speed so you don't have to suffer through it slowly, or you can always jump off to the next chapter. We used to have a saying when working on mechanical items: cross threads are better than no threads, but in this case that's really not the case, because if you're trying to put something back together, it's best to try to get a good start to your threads, and unfortunately I have a little issue with this one screw. I'm going to have to see what I can do to repair the start of it, because it was starting to go into that nut at an angle. I thought I cleaned these up to the best of my ability, and I also had 3 nuts on each one of these when I went to go cut them. And when you take the nuts off, usually that action alone gives you a good start of your thread, but in this case I'm just running into some difficulty I wish I didn't have. I just don't want the damage to continue any further to the point where the screw or the nut becomes junk, because I'd like to use these items. But I think I got a little situation I'm going to have to work on off camera, so we'll get back to you in a little bit. Okay, I've got it so it'll start and run into the nut both ways. I'm just going to have to be a little careful starting it, because it's a little coarse right at the end. It's boogered up a little bit, but if I line it up well, can get it to go in successfully by hand, which is what we want. So I didn't damage things too bad. That's just going to be a little bit of a challenge to get it on properly, and then proceed with tightening this down and putting some locking compound behind it. So we'll carry on again at a higher rate of speed. I figure while I have it exposed, I'll show you this little capacitor array that's on the part of the original install for this particular item. Looks like it's got 6 sections and a common, but no values, so it would be a part particularly made for this item by a unknown manufacturer, because it's not really marked. So if you have a lot of failures, you just have to start replacing them with discrete components until you get to where you need to for the proper values. So okay, going to continue on with the higher speed work. And I don't know how I managed to do it, but I am missing a piece of hardware. I should have a... Oh, never mind, I found it. A lock nut. I've got a little magnetic retrieval tool on the desk here, and it managed to retrieve the lock nut for me, so without me prompting it to do so. We're going to get down to our last switch here. This is going to be the one with the electrolytic capacitors, and this one here is, I'm going to have to go through a little more effort of cleaning it. I don't know if you can see, it's got some pretty well built up residue, even some green corrosion on that brass spring plate. I'm going to have to clean that up a bit, so I'll get the rest of this assembly off camera while I concentrate, or at least get it to a point where nothing metallic and sharp will scrape up the face there, while I concentrate my efforts on cleaning this guy up. It's going to take a little more. I've got some acetone and some Q-tips I can do a little work on it with, and hopefully get in there and get a good version of cleaning. It's kind of surprising the corrosion got so bad in a few spots like that, but it happened. Nothing you can do about it but get some access to it and work on it. Try to get the camera and the switch in the view a little more here. There we go. Can't say what exactly caused the larger amount of corrosion to appear on this guy, but it's just a bit ugly in general. Try to avoid hitting it with any wholesale type of spray or cleaner, because I just want to be a little bit kinder to the rest of the switch. That's why I'm going through the effort of getting in here in a mechanical means. Can't say that a spray would clean everything up well without a little mechanical intervention either. I'm getting a good amount of crud off of here, so It's not surprising in a way. I mean, it's just this thing sat for so long. And I did spray the switch deck with some cleaner and some D5 already. I'll probably touch it up with a little more D5 before I put everything back in the enclosure. It's kind of nice, this, along with the spring indent over here, the back portion's cut out a little more. So as I rotate that around, it allows me to get to different areas to get a little mechanical cleaning better. I got a good majority of things cleaned up. Go ahead and apply some dielectric grease back into that area. Takes a little bit of time and patience because you have to manipulate the switch to get access to different areas and the indents to get the lubrication into it. And then my last thing is I have some Teflon particle infused oil. The Triflow brand. A couple of drops of that, small drops on the shaft, and let it sink in a little bit and rotate it a few times. And probably just take a little small amount of D5 and get it in there as well. Both sides. Okay, that should do it for the cleaning and lubrication. And the one thing I'm doing different from the original assembly is they gave you only one star washer, and originally when I was taking this apart, the star washer was on the back side here, and I can see where that would be a good idea to keep the switch from turning, the body of the switch from turning, but in this case this has a mechanical pin protruding from the mounting face, and the panel has a hole that lines up with that pin. So that would keep it from rotating anyways, no matter what, and that little hex area that's on there is enough of a base to flatten onto the back side of the surface. So what I'm doing is I'm repositioning the washer onto the front because it will have a better chance of keeping the front hex washer from rotating and becoming loose. That is my plan. It doesn't disturb anything as far as how far the knob is set off from the front of the panel or anything. It doesn't seem like it. I checked already, and it doesn't really look like it adds any type of physical conflict with anything else. So I'm going to go ahead and tighten this guy down, trying not to scratch my newly clear coated panel. And that should be all the switch reinstallation on the front. The only other thing I have to do is to take off my little pieces of tape off of everything. I think the clear coat helped stick them on in some cases here. This guy here should have a spring-loaded action with a latch to it, and I got a little clear coat on it, but there we go. If I wiggle it and push it in a little bit, it latches the switch just like it's supposed to. So push the switch back over, it releases the spring and allows it to go back. So that worked out nice, and I have to uncover my jacks. I did clean these jacks up earlier, and I am going to have to make some cords for this. I don't have any cords that are made up with 2mm plugs on them. I have the plugs, and I have some little off-brand J-hook connectors. I'll probably make 2 sets of cords for this, thinking that might possibly use the resistance and a capacitance substitution at the same time. I have some 18 gauge 600 volt silicone covered insulated wire. It's not component lead wire. It doesn't have that double layer to it. I didn't really want the double layer. This is a fine braid, so it'll be flexible, but yet it won't have as thick a coating on it. And as long as it has that higher rated insulation and the silicone cover gives it some protection from heat from an errant soldering iron contact. Boy, some of this stuff's got some crud in there. I don't know how the heck they got them. Yeah, I figure that just stick with the silicone wire for the voltage rating's good. Boy, I thought I cleaned these and I had some dirt in them, so I might have to make another attempt at cleaning them. Don't know what happened there. Okay, that is the panel without all of its tape, ready for some knobs, but I will not put the knobs on until I get done with a few soldering iron items I have to do in back. I have to reconnect all of my boy, that silver paint I thought was going to be a good corrosion protection, and it almost looks like corrosion's leaking up through there already. Well, maybe I can hand brush on another coat with a paintbrush or something like that. Sometimes I think Rust-Oleum, although they advertise to a certain quality of things, or to accomplish rust prevention or rust proofing, sometimes I think they aren't all what they're cracked up to be. So I have a few things going on with the panel. I'm going to get a piece of paper towel to put on top of that plastic cup for a little more protection. The plastic couple is a good spacer. So I have to reconnect some wiring. I have the low and the high range for these, as well as the common return. On the low side, or common, or whatever you want to call it. Solder back on here. Get a soldering iron ready to go. This terminal should go to the center of the switch. The low resistor deck, the 1 watt, is going to be switched to the left, which will be the connection to the right once I turn it upside down. Going to have to get committed with restoring all my connections here. Try to reuse all the existing wires. Now the outside deck of these resistors are the smaller resistors, but they are the higher value. They have orange. Boy, my cleaner took a lot of that off. Green goes into the mega ohm range, so that one's going to go to the switch position on the left, which will be the switch position on the right once I turn it the other way around, and this guy will be the opposite of that. And I'm going to take him under there. They did not use a lot of extra slack on this guy. Try to get a good wraparound mechanical connection here. Oops, come on. Boy, oh boy. Okay, got that wire on there. Oh, what did I say it was going to do? I actually put that on the wrong side. I caught it. I didn't solder it, thankfully. That one is to the switch deck with the higher resistance components. And there we go, I broke the wire. So and it won't reach, so I will have to get in and resolder that. But in the meantime, this one will connect to the lower range resistors without too much effort. Other one I'll have to rework a solid wire onto the terminals. Let me see if I can get myself in here. Don't have the best lighting for that one particular spot, but do what I can here. I've got to take the soldering iron in straight from this angle. Oh man. I do not want to get too aggressive with that terminal. It doesn't seem real strong. They have to start getting some solder wick involved again. I was hoping to not get the point where I had to rework everything on these like this, but if I would have paid attention to what I was doing, I probably would have got away with it the first time. But wow, there was some solder on there. I have to try to get in there as gingerly as possible, get that wire loose. You can see it's hanging on for dear life. There we go. Man, just trying to keep it moving, hoping that the solder will crystallize. I won't bond well mechanically, but it's on there. This is one part of the hobby or being a technician where patience really comes into play. If you're in a hurry to do things, if you get frustrated too fast, this might not be the hobby for you. I dabble in a few other things in order to either on a hobby basis or to keep the household running. One of them is mechanics, and sometimes as a mechanic you have to employ brute force methods and means in order to accomplish what you want. In the case of electronics, brute force rarely gets you far. It'll usually get you things that are broken to the point where you're not going to be repaired without replacing the whole unit, or just not even be able to be repaired at all. So take your time, take a deep breath sometimes, and rethink what you're doing and how you want to try to do it on your next attempt if you failed the first time. Okay, I have the wire loose totally. Just have to pull it out gingerly. If I can cut it close to where I need to take it out. Yay. Did not damage the terminal, and the wire is gone. Gotta find some appropriate solid wire. I've got some bare copper I could use. It will work just fine. Oops. Drifted off camera there, sorry. Can't really see what I'm doing too well on that switch deck anyways. I'd have to move the camera to a point where it would be blocking my view, so. Okay, should be able to apply solder to those three connections. Good. And my last connection I'm going to have to make with the higher wattage soldering gun, because the And I am back, and I am sorry. I ended up having a audio-video synchronization issue. I record the audio track on a separate software off of the camera because the microphone I use has a better audio quality than the camera microphone does, so I have to reattach my common wire to my common ring of resistor connections on the array here, so I'm going to go ahead and perpetrate that. Takes a little more wattage to get some solder to melt onto this. Okay. Unless you get a really good mechanical connection, you just get that little bit of a crystallized look to it. So that should get me my connections back for my low wattage resistors. The high wattage ones I have to double check something on, since I have two connections on that one. I think this connection wants to this wire goes underneath everybody, but I think that connection went to the switch position on the left, which should be or on the right facing it from the bottom, which is the left on the front, which should be the higher values. Try to get this common wire routed underneath these other ones a little bit, since I had so much manipulation going on before. Yeah, man. If I can do that, I can route the slack a little better here. Just don't want to get that in the way of where I'm soldering. That looks a little better. Okay. I'm going to take an ohm meter just to check and see check my connections here. A little better. I don't want to go to min-max. Give me that, and out of these two I have the common, which is my black wire, which is this one. That one is 252 ohms on the meter. And this should hopefully be a lower value. 2.7 ohms. So that means that's set to the first switch position, I think, because each one of those values is 2.5 ohms. So this one's the common on the switch. Every now and then I actually double check something before I work on it so I don't goof it up too bad. Okay, the video stopped. I had the camera stopped, had to restart it again. Try my best to not break this wire for using it, but that one I already measured. That is the lower value out of the resistor array. Oh boy, I figure the wire broke. I can possibly get enough slack out of it where I can get at least a hook on the terminal. We'll go with that. Looks like it's got a good connection. Okay. Now the third group there didn't disconnect anything. Everything stayed within that switch. Third group here, everything stayed within that switch and cluster there, and the components are all, none of the leads are shorted together. This one's insulated from the other one. Everything else is clear. Oh, there's one peculiarity about this. The substitution function on this list is a silicon diode and then a selenium diode. The half amp and 800 peak inverse volts. All they do for the selenium is they add a resistor, a 47 ohm, probably a 5, maybe a 10 watt resistor in series. That simulates the voltage drop on a selenium rectifier. That's all they do, so it's not really a true replication of a selenium diode. Okay, now capacitor part is the tricky one. We have two leads on this rotary switch that had things soldered to them. The one looks like the common for the top deck. The second looks like the common for the bottom. I am thinking those needed to go to this yellow wire here. I don't know if there's any separation, and boy, I didn't write this down. I know I took some pictures or video of it before. I do have another one I can take a look at. I did mention before that I did get my hands on another one of these puppies for a reasonable price, and it's a little worse for wear than the other one, but I can use it to check the wiring, and on this one there is a small wire that goes from the top of the far left side of the switch to the connection there, and then the yellow wire goes to the bottom one. So there's a wire I must have removed. No, I didn't remove it. It's right here. Okay. That one goes to that pin there, but it's currently occupied with some solder, so I have to clear that off. More solder wick is in play. It's amazing how cluttered a work area you can get when you start working. Okay, I have a couple of good connection points there. Probably clean up this wire a bit as well. Tell you what, that solder wick does conduct heat fairly well. I had my fingers a couple inches down from where that iron was, and oh, it's gotten hot. Made a mess of conflicting stuff here. I had my dielectric grease kind of close to my knobs, and sure enough, I ended up getting the dielectric grease all over said knobs. Not the worst thing that could happen, but at least I'll take it off. Okay, those two guys out of the way. Okay, so I've got him. I've got a little bit of errant solder on that other wire as well. Try to get him off. Okay. Now I have to get some manipulation in with the needle nose pliers, which are here. Get the test leads and the meter out of the way here because I don't need those right now. Okay. Everything's gone places I didn't expect it was going, but okay. Kind of back in camera view here, but I'll a little bit of a zoom in. This wire from the bottom of that slider switch goes to this terminal. And I got it. So pardon the afternoon freight train noise. I am about 2 city blocks away from a busy Chicago metropolitan train track that has freight and commuter rail on it. That's a freight train. Okay. Like 2 good connections, and my last connections, I need all the commons from my capacitors to go to this switch terminal connection here. Actually, to both of these switch terminal connections, since all the commons are together, and not sure exactly how I'm going to go about doing that. I might take a solid piece of wire, pass it through from one to the other, and then bridge the other connections on. Yes, if you don't try something new and fail every now and then, you might be missing out on something, because you might actually try something new and succeed. Well, that looks like it wants to play. My only problem is I need 2 more hands. I like to keep these wires in a position where they're fairly vertical and putting some pressure from left to right. That's not happening right now. That might do it. Let's get this heat shrink up a little more so it doesn't melt in the process. And hope for the best here. Oh, it's coming apart on me. Then you have one wire kind of sticking in place. The insulation's melting on it though, and the other 2 already came apart. I'll have to figure out something in a little bit here, so stay tuned. Well, it was not the prettiest thing in the world, but I managed to get all 3 wires soldered to that little piece I created there, so it's a good enough connection where it shouldn't have an issue with it. And the bottom line also is it's once it's inside the enclosure, it's not like it's moving around, so. Be nice if I can get this little piece inside the tubing. There we go. That slider heat shrink down. Get that to stay in a good spot. And I'm sure there's more than one way to accomplish that, but that's the way that I chose for now. And I think the thing to do from here is to tidy up a little bit and give it one more going over before we end up putting it all back into the enclosure. I should have all my connections reestablished, everything insulated properly. Oh, I did want to try to get a little bit more of that flux cleaned up on that switch. Boy, that stuff is just crusty hits on there. It's pretty bad when you can scrape it off. It's just, one would hope that it would just wipe off with a little bit of maybe acetone or isopropyl alcohol, but this older this has the flux from the original connections plus whatever I added when I was doing my soldering work, so it's got a little buildup to it. Better than what it was, and I got a dirty swab to prove it. So. Okay, I'm going to zoom it out and go back to some component testing. I should have everything functional within a range now. Oh, I don't have, the only thing I don't have is all my knobs mounted. I can go along and start doing that. I'd like to put my set screws in there and put a little bit of blue Loctite on those. I can speed up this part of the video. Okay, the front panel is completed for the restoration. I said I've got to go through here and figure out why I had so much debris in this guy, and probably clean these out again. And I've got a couple of small pieces of tape stuck here, there, and everywhere. But for the most part, it's done. So I need to probably get something to prop this up a little bit, get myself a couple of connection pieces again, and take some measurements. What do I have where I can prop this up a little bit? Try and see if I can use a bottle. I don't know. Let's see here. Oh, it's half-assed. Okay. Get some tools out of the way. The home stretch on a project is always good. Especially when you think you've actually accomplished something. Some days, like I said, activity and accomplishment are not two of the same. They're one of the same. Okay. Here goes everything. Pretty good lighting on the meter. This is in the R times 1 range. $10 ohms, 18 ohms, 33 ohms, 56, 100, 180, 330, 32.9K. Uh-oh. That's a goofer. I got the wrong value component in there. It's so the way we double check things. 560 is a 556. 1K is a 1K. 1.8K is a 1.79. 3.3 is a 3.24. And a 5.6 is a 5.9. A little on the high side, but not too bad. So we're going to go times 1,000, so that should bring us up to mega ohm range. It's a little high. That would just be outside of tolerance on the high end, but I'm not going to worry about that. 3.3K is a 3.3 meg. 3.2, 1.8 meg is a 1.95. 1 meg is a 1.06. 560 is a 553 mega ohm. 355 330 is a little on the high side. 180 is a 196K. 100 is a 97K. 56 is a 53K. 33 is a 35 kilo ohm. So these two components are actually the same value in the different ranges. 18K is a 17.48, and a 10K is a 9.7. So that one's behaving itself. Except for that one. That is supposed to be 355 ohms. It is 355 kilo ohms. So I will have to deal with that momentarily. Now we're going into the 20 watt resistor. These go up in increments of 2.5 ohms at first until it hits between 10 and 15, that it jumps to 5. Then it goes to a second resistor array where it goes up in values of 25 until it gets to the last one. It goes up to 50. So we'll see that. It's 2.5, 5 ohms, 7.5 is 8.2, 10 ohms is a 10.85. 15 is a 15. 25 is a 26 ohm. 50 is a 53. 75 is a 81. 100 is a 109. A 150 is a 160. So we're going to go up 100 times in value. 150 is a 15.6K. Should be close to a 10K. 7.5K is a 7.7. 5K is a 4.9K. Should be a 2.5 is a 2.3K. So 1.5K there. 1K. 750 ohms. 500 ohms. And 250 ohms. So those are pretty good actors there. So we're going to go to our capacitance. I'm just going to check capacitance first, then I'll go back and check the diode functioning. I'm just going to use this meter for capacitance to expedite it. 0.5 is a 453 nano. That's touching the low side but acceptable. This should be 100 nano. It is. Be a 50 nano. It is. 20 nanos, 22. 10 nanos, 10 nano. 5 nanos, 4.75. 2.5 nano is a 2.2. Should be close to a 1 nano. It is. It's a 005, a 004647, and a 001 nano. So that's pretty good. So now we're going to go to our electrolytics. So in this case I have to push this, I have to slide this over, push this down to get the switch to latch. I'm going to start out in our A value range. It's 2 micro. This is 4. Little on the high side. Not too bad though. 10 is an 11. 20 is a 19. 40 is a 46. A little high, but no harm, no foul. Should be a 60. Comes up as 66. Should be 80. Comes up as a 91. 100. 106. 120. It's a 150. Comes up as a 170. And this should be 250. It comes up as a 271. Oh. So we're going to... Polarity really doesn't make a difference. It's going in a charging time constant, but just got to see how things go. That should be an open circuit, and it basically is. This is 125 micro. Comes up as a 134. Should be an 80, comes up as a 92. Should be a 40, comes up as a 43. 30 comes up as a 34. 25 comes up as a 28. 25 also comes up as a 28. That should be a 10, comes up as a 9.4. 6 comes up as a 7.06. And that 2 comes up as a 2. My only mystery here is I don't know if I can use... I'll have to check it out later. I'm not sure if you can use the A and the B at the same time. I'm thinking not, because of the way the switch combines some of these values. It's probably not a good idea to try it. If anything, if you find yourself needing to substitute 2 capacitors, I'd get either another discrete component to hook up to a couple of test leads and hook onto a circuit, or get another capacitor substitution box separately to hook up to it. So, one thing I did want to check is when the switch function slides to the regular protection to discharge, does it? It does not. It does not connect the resistor to the internal bleed resistors to the front panel. It's an open circuit. So that, and just to show how that works, I'm going to hook onto the back here to the 2 microfarad value, hopefully. So one of the two microfarad values into the common, and right now we should see resistive load. There we go, 500 ohms in the second position. So as soon as if I was using that value capacitor and it held the voltage charge on it, as soon as this switch slides from the capacitor to the left position, it discharges the capacitor within the unit to keep it from possibly putting a voltage surge on the next item that you're going to use with that capacitor. So it would be a good thing to make sure that you didn't change this knob before you let this switch go over to the left position. So other than fixing my little boo-boo on my resistor, I'm going to do that off camera, come back, and then go over the last few things of putting the cabinet together. And the offending triple orange resistor has been replaced with an orange brown, which should give me a proper value of 330 ohms. So we're going to retest that one just for the hell of it. I've just been away from the hobby for so long, and I don't know if you heard me mention before, but most of my life involved reading a color code, but the color code was a telecommunications cable color code, which most people are not familiar with, and it does not cross over to regular electronics work, and it is kind of something that I can pretty much forget now and go back to trying to remember the color code used for electronic component numbering. It's going to be a little bit of a struggle to get back to that point, but it should happen. It's partially there in my brain. It's just that I didn't compute for some reason when I put that resistor in. So yes, I did replace it, and yes, I did put the wrong component in. So we'll go back to one more check of our 330 ohm. Get the meter in there, and this one, and this one, and a little better. 180 is next to it. There's a 330 and there's a 560 on the other side of it. So we are going to call that properly repaired, and except for a little bit, like I said, the mega ohm resistor value for the 5.6 comes up probably out of tolerance, but that's one that I'll rarely ever use, and if you're dealing with values that high, odds are you can be off that much and things will still work. So we'll get into the nitty-gritty of trying to stuff all this stuff back into the cabinet after clearing off some more space. Now I should have some stainless steel screws available, which I do, in order to fasten everything back in the cabinet. Tidy up the bench a little bit. Bench, desk, whatever you want to call it. Put a few things away I don't want to lose either. I don't want to lose these banana plugs. They're going to come in handy. There's one little thing I thought about doing due to the fact that the steel cabinet edge on this thing is so thin, and it did suffer the damage in that one spot. I'll show you in a minute, but I'm going to hopefully get our capacitors back into their resting place. Nesting place. I didn't check to see how tight of a fit these were before. They didn't change diameter or anything. They're a little snug, and the thing with that was I did not tighten the screws and back all the way yet, thinking that they might be a little bit of a snug fit, so I'm going to do that. I just got the bracket in place and tightening up the top one, pulled the bottom one into place a little bit. Pulled it in and popped it out of place maybe. I've got to see what happened here. It might have rocked it away too far. Yeah, I think I did something a little bit on the strange side here. Considering these were such short sheet metal screws. .3/16 probably would have been nice. Oh boy, okay, here we go. I'm going to have to push that back onto it. I was hoping that these screws would kind of snug up the physical area of those electrolytics, and I guess they do. Okay. And the electrolytics are back in place, and besides my weird numbers on them, you'd never even know that anybody worked on them. And then for the face installation, there's a little bit of a strange arrangement that the bottom screws, the front panel screws in from the bottom like this. This is where I left that little relief for the adhesive under here. Oh. Hot potato. Then there's a hole in the side of the cabinet that you have to get a hole in this plate to line up with. Where's my little... use a pick for alignment here. There we go. And they would repeat the process on the other side. Probably wouldn't hurt to have some longer screws. I'm not sure if the screws that were in here were even stock or even the originals. Okay. Well, it looks like the screws are about aligned there, and hopefully the feet will behave and stay in place. And for the most part, that's it. Now here's the only other thing I wanted to add to this guy. That metal edge along here, like I said, it's awful slim, and it might get dented or bent or even nicked or bumped into easily from being exposed. And I was thinking about protecting it with something, and I came up with, if I can find it, oh, here we go. I was thinking about something akin to automotive trim as far as a door edge protector, and I managed to source online on Amazon of all places a very thin rubber or plastic material for a door edge protector. And it looks like the only place that there would be a little bit of a conflict would be where this edge tapers down here on this part, because this is only so thick. This has a glue on the inside of it that I can probably, oh, it has a removable strip as well. I don't know if I'd want to put that inside or outside, but what I might do is, to start things out, I'll probably put the glue on the outside so that will keep it from peeling away from things. But on the inside, I'll probably start by cutting a small taper in for about an inch or so, just to keep it from bumping into that face panel until it gets a little higher. So I'll work on doing that. I was wondering if this was going to be something that I would need to use the heat gun on to get the adhesive to work, but seeing that this has this peel and stick, oh boy, the adhesive kind of came right out too. Ain't great. Still might use the heat gun. Let's see how this goes here. Well, it looks like that's seating on there very nicely. Can't say this adhesive is sticking very well at all. The edge protection function seems to be nice, though. Like I said, I'll apply some heat and some pressure to it in a minute and see how things go once I get this in place and cut the size. It does give it a nice dressed look, though. I'll give it that. So even if I have to supplement this adhesive with a thin bead of silicone, at least I'll get this cut to size. It does give it a nice finished look. I'll give it that. It's something that was lacking from the original manufacturer. I mean, granted, all this stuff is, as they say, it's always built to a price point. They're only going to spend so much money on putting a product out the door, and somebody's going to look at this a lot of times more for functionality than for its looks, but then you would like it constructed in a way where over the years it's going to hold its looks fairly well without having any issues for getting damaged. Okay, that's that, and I'll cut away a little bit on this end here at an angle. Apparently the adhesive was good at getting in the way of the scissors, but yeah, I might find myself putting a thin bead of silicone in that middle. I can try to apply some heat and pressure to it, but don't know if that's going to be a fix. I think it's actually making it looser. It's still that adhesive, as they say, is no bueno. It's really not doing anything to hold anything in place here. So it's a little disappointing, but it's definitely lost its adhesive function. Like I said, I'll still keep it because it's still thin bead of silicone to make it usable. It's just that this stuff is really not sticky at all. Most of the stuff I've seen, it didn't even have any type of tape to cover the adhesive. So this particular item, probably to be avoided if you see it. I will make it work, just with a little bit extra to it. So we'll cut away from the tape for that, and then we'll come back to it. The finished product. And here is my version of the refinished product. I ended up getting that edge trim on there. I removed all of the adhesive tape that came with it that was basically totally useless, and put some of that B7000 glue in there. That stuff's like a combination of silicone and the model airplane cement. Like I said, that should, once that sets up, that should hold it fairly well. The only thing I'm worried about is the fact that this edge trim might interfere with the removal of the panel if somebody needed to go in to work on components again. But small price to pay. You can pull it off, clean things up, re-glue it back on. But other than that, feet seem to be staying in place just fine, and will keep the cabinet device from shifting around on most surfaces, I think. And that heat shrink on the handle, refinishing the handle, new hardware on the back and sides, that just about looking as good as new and performing pretty close, I'm sure, considering, like I said, beside that one 5.6 megohm resistor measuring out to 6.2. So this one is one of the two that I have to work on, and the second one I'm going to just go over something in a little bit. I don't know how much I've mentioned or talked about the resistor, the power resistors in the last unit. This one here has got a little bit different components than the first one had. The dynamite stick arrays are about the same, I think, although one of them is a little larger in length, so that might add a little complexity to the challenge. Might be just because of the larger value capacitor in there, but should come apart about the same and work out about the same. This guy is going to have the same challenges as far as testing all the values, seeing which ones are intolerance. This one I know for sure has got damage. It has, if you look, it looks a little unhappy. It looks like it's got some resistive issues to it, and I can take a quick look at things. The problem with those is there's no, they were made by Milwaukee. That place is not in business. There's no current part numbers, seeing that these are so old, and I've never even heard of the company Milwaukee as far as any type of electronic components advertised within such a long time that I can't say it's even viable to try to look for good replacements for these. There's different values in these going down the line. We're going to check some of them out. They connect like this. The first three of these are going to be 2.5 ohms a piece. So this 2.55, 7.5, 10, and then this third one should be a 5 ohm resistance. But we have a problem. It is not measuring very well at all. That one measures out to kilo ohms. It should measure the jump from this one. Oh no, maybe that is the kilo ohm resistor. 11 and 15 kilo ohms. Come on. Yeah, that one might be okay. This one. Let's start at the low range then. This should be 2.5. It's pretty close. You know what? Let me delta out this meter to a 0 value. .3. This one should be 5 ohms. It is. This should be a 7.5, 7.9. This one should be 10 ohms. It is, and this should be 15. That is okay. So we're going to go to the next one here. Oh, sorry. 25 ohms. Now there is a problem here because it jumps from 25 ohms to 107 ohms. That should not be the case. Front panel says it should go from 25 ohms to 50 ohms. So each one of these should be a 25 ohm value going up. If I go from here to here, we should have 25. No, we have 82. Here to here is 25. Close enough. Here to here is 25, and then this one to this one is 50. Okay, so that one makes sense. Now going to the next bunch here, we're going to go back down. Our first jump on that one should be 220 ohms. It's 330. It's a little on the high side. And then each one should be that one's also 350. That one's no bueno. It's in the mega ohm range. This thing has a lot of hard life here. That one's also in the mega ohm range. Somebody really laid onto these guys. That one's a 500 ohm resistor. That last one is probably the only one that's good. Now, the problem with this is if you've got one bad in an array, if it's anything other than totally open, which these aren't, if you try to replace these by putting something parallel with them, you don't know how it's going to behave over time. And I think the only two resistors that are really behaving properly are the first range and the fourth range, even though this one does show some sign of some heat damage. It was holding close to its proper values. Does have a little problem getting continuity. That's a 2.5, should be 5 ohm, 7.5, 10, and 15, or 10 and I take that back, 25. That last value's oh no, 15. Okay, the last value is 5 ohm. So the first one is good, fourth one's good, second and third are not good. I'm debating whether to replace all of these with some updated resistors or just replace the second and the third element. And considering that this isn't going to see a lot of usage for one, for two, if I was going to keep one, it would probably be this one because it's in a little worse for wear shape. It'll need a little more modification. I'd probably let that other one go as far as maybe having some resale value. Oh, by the way, if you wanted to take a view and see how they joined all those common wires on this one, I don't know if these are kit or factory. I'm going to presume this is a factory assembly, but it's not real pretty when you put them all on the switch connections either. So what I did, who's to say it was worse or better? At least my way, you had the possibility of removing or replacing the wires and not having to go into the binding or into the the solder lugs on the switch. So I'm going to go over this guy, take a look, see what components need to be replaced, and then in a future part of this I will show how I'm going to replace these resistors and then go through everything else for functionality in the switches, check, make sure everything's okay, and probably give the other one the same cosmetic treatment as the other one. It's not in bad shape, it's just got a little more rust on these rivets. I have to polish these rivets up. The panel's got more scratches on it. It's got some kind of strange crazing or something in some spots on the paint where the paint is shrinking, but I'll probably just clean that up, clear coat over it. Everything else is in pretty good shape. But this guy might need a little work to get him to stay properly. There we go. Little switch over here. It's got a Got to work to get it to catch a little bit, but it seems to catch okay. So that's my plans for the next part of something on these, but hopefully I can make this unit look something at least they're about as good as the previous one I worked on and function as well. It's just that I'm going to have some problems with those resistors. So I hope you enjoyed this episode in part, and if you have any questions or comments, please feel free to put them in the comments section. And if you would like to see more content like this, please feel free to subscribe so you will be notified of my next exploits with trying to repair something. I hope that you are well, and hope to see you soon. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.